Okay, students, you are watching the help video for this assignment here. So if this is not the assignment that you wanted to see, then you are on the wrong video, page 382, numbers 5 through 13. Excuse me, sorry, and numbers 15 through 26. Okay, so without any further ado, for your pleasure and enjoyment, here we go. Let's take a look at number 5. All right, number 5. We are determining whether the two triangles are similar. If they are similar, write a similarity statement and find the scale factor. Okay, I guess real quick I'm going to try to be pretty, not sloppy, but I'm not going to spend a lot of time on writing all this stuff down perfectly. Okay, we have CDE, so CDE, and triangle FGH. FGH, and we have sides 9, 12, 15. So 9, 12, 15. All this is in your book, of course, then 6, 8, 10. All right, let's see if these two triangles are similar using the side similarity. Smallest side is 9, smallest side is 6, so 9 over 6 equals, middle size is 12, middle one is 8, so 12 over 8, and then 15 is the biggest side, and that would go over the biggest side over here, which is 15 over 10. Well, if you reduce, you get 3 halves. Reduce and you get 3 halves, and reduce and you get 3 halves. So we are good. So now we have proven by side proportionality that these two triangles are similar. Now they want you to write a similar statement. So we would say triangle CDE is similar to triangle FGH. Now they want us to find the scale factor of triangle B to triangle A. Well, if you're looking at your book, that's triangle B. This is triangle A. And it says find the scale factor of B to A. So of B means you start with B, pick a side. I'll pick this side. So 6 over. Then because it said triangle B to A goes in the bottom. What side goes with 6? 9 does. So 6 over 9. Reduce that and you get 2/3. So the scale factor of triangle B to triangle A is, and then we reduce 6/9, we get 2/3. There's a scale factor. All right, let's take a look at number 6. Number 6, and the triangles look something like this. And good enough anyways. And then we have JKL, so JKL, and PQR, so PQR. And 15, 25, 15, 25, and 20, 12, 20, and 16. So 12, 20, 16. All right, let's see if they're similar. Smallest side is 15. Over smallest side over here is 12. The middle size is 20, and the middle size over here is 16, and then the biggest side over here is 25, and that would correspond with the biggest side over here, which is 20. And let's see what we get. If you reduce these by 3, you get 5/4. If you reduce these by 4, you get 5/4. And if you reduce these two numbers here, this fraction by 5, you get 5/4. So yes, they are similar. So our similar statement would be triangle JKL is similar to triangle PQR. And then they want us to find the scale factor from triangle B, or the scale factor of B to A. So pick a side with B. We'll pick 16 and match that up with this side over here, 20. Reduce that and you get 4/5. So what's the scale factor of triangle B to triangle A? 4/5. 4/5. All right, let's go ahead and try problem number 7. All right, problem number 7, we have a triangle. I'm going to go ahead and quit drawing the triangles. I am not trying to be lazy, but I am trying to save time, and you guys have the triangles right there in your book, okay? So with that in mind, let's see what happens here. I'm going to find the smallest side in triangle PQR, and that's 4, and match that up with the smallest side near a triangle, that's 5, equals. Now find the next size in the first triangle, PQR. Well, that would be 4 again. And then the next, go to the other triangle, the next biggest side would be 5. And now we'll go back to the first triangle, the biggest side is 5. And go to the other triangle, the biggest side is 6. So 4 corresponds with 5, 4 corresponds with 5, 5 corresponds with 6. If you reduce all these fractions, and by the way, they can't be reduced, are all three of these fractions equal? No, they are not. So no, these two triangles are not similar. All right, let's take a look at number 8. Number 8. All right. I really do feel that's not the best idea to not draw the triangle, so I'm going to do that very quickly. 18, 24, and 36. And 15, 30, and 20. All right, here we go. Let's knock this out. Smallest side over here is 18, and that would correspond with the smallest side over here, which is 15. Let's see, the next biggest side is 24, and that would correspond with 20 over here, so 24 over 20. And then our longest side, 36, would go over 30. Let's reduce and see what we get. 3 goes into both of these, you would get 6/5. 4 goes into both of these numbers, so you would get 6/5. And let's see, 6 goes into both of these numbers, and you would get 6/5. So yes, these two triangles are similar. Now here's your statement. If you'll look in your book, you'll see where I'm getting these letters. It would be triangle PQR. Nope, that's wrong. Triangle MNP is similar to triangle TSR. And this is triangle B, and this is triangle A. The scale factor of B to A, pick a side over here, 15 we'll say. And 15 corresponds with 18, so 15 over 18. So the scale factor is 5/6. 5/6. All right, let's take a look at number 9. Number 9. Okay, our triangles look somewhat like this. And we have 16, 8, and 12. So 16, 8, and 12. And then we have 12, 24, and 18. All right, smallest side over here is 8. Smallest side over here is 12, so they go together. The middle side would be 12, and the middle side over here would be 24, so 12 over 24. Can we stop right there, please? If you reduce 8/12, oh, sorry about that. The middle side over here is not 24, the middle side is 18, so it would be 12 over 18. And then our biggest side over here is 16, which would correspond with the biggest side over here, which is 24. Well, let's reduce. 4 goes into 8 and 12. That would leave us with 2/3. 3 goes into, no, 6 goes into both of these numbers. That would leave us with 2/3. And 8 goes into both of these numbers here. 16 and 24 leaves with 2/3. So yes, the two triangles are similar. And our statement would be triangle UVW is similar to triangle JGH. And this is triangle B. This is triangle A. The scale factor of B to A, we'll just choose 12 for the fun of it. What side corresponds to 12? 8 does. And if you reduce that, you will get 3/2. 3/2. All right? Which is the scale factor of B to A. Moving on to number 10. Number 10. Okay, we have a triangle that looks like this, and a triangle that looks like this, more or less. And we have a 6, a 9, 11, and an 8, 12, and 14. 8, 12, and 14. All right, here we go. Let's go with the smallest side over here, which is 6, corresponding with the smallest side over here, which is 8. The middle side over here is 9, and the middle side over here is 12. And the biggest side over here is 11. We can stop right there because 11 over 14 is not going to equal these fractions over here. So the answer is no. They are not similar. No. All right, let's see what else we got here. Okay, we're on numbers 11, 12, and 13. I'm going to go pretty fast through these, okay? Getting a little late here at night, and let's see what we got here. All right. There's one triangle. All right, now let's see. We got a 4.5, 8, 7.5, 6, 8, and 12. 3, 4, and 5. Okay, here we go. Now, the directions say is either RST or XYZ similar to ABC. So we're going to first of all see if this triangle is similar to this triangle, and then we're going to see if this triangle is similar to this triangle. So let's see what happens here, okay? Let's start off with this triangle right here. Smallest side is 6, so we'd have 6 over smallest side over here is 4.5 equals the middle side is 8, the middle side over here is 7.5, and then the longest side is 12, and the longest side over here is 7.5. And let's see if I did this right. Something 6 over 4.5, and then I said 8. Okay, this right here should be, yeah, that's right, 8 over 7.5, and then 12 should go over 8. 12 over 8. All right, here we go. Well, first of all, I've told you before, 6 over 4.5 is the same thing as, if this helps you, 60 over 45. In other words, I move the decimal one place, I move the decimal one place, so 60 over 45. So this is the same as 80 over 75, and then 12 over 8. Now let's go ahead and reduce each fraction. 5 would go into both of these. We'd get 12 ninths and then 4 thirds. So 15 goes in both of those numbers. And let's see. 5 would go into both of these. It would be 16 over 15. And so we can stop right there. There's no way these fractions are going to be equal. So this triangle here is not similar to this one. Now let's try this triangle here and compare it to this triangle over here. So let's find the smallest side over here is 4.5, and that will go over the smallest side over here, which is 3, and the medium size side is 7.5, and that would go with 4, and the biggest side over here is 8, and that would go with 5 over here. Now, of course, 4.5 is the same thing as, move the decimal here, 45 over 30. Move the decimal to here, be 75 over 40. So if we reduce 45 over 30, 15 goes into both of these numbers. We would get 3 over 2. And then if we, let's see, wanted to, yeah, this will not work. Nope, if you reduce this, you will not get 3/2. You will not. You will get 15 over 8, but that's about it. And over here, make sure I copied this correctly. Okay, and moving on, sorry about the delay there. So these two are not equal, so this triangle here is also not similar to this triangle over here. Okay, let's move on and try number 12. Number 12. All right, here we go. We've got a small triangle that looks like this, and then one that's a little bigger, and then one that's a lot bigger. And let's label our sides quickly. We have a 4, 8, and a 10, so 4, 8, 10. And we have a 6, 10, and 12, so 6, 10, and 12. And we have 10, 20, and 25, so 10, 20, 25. Okay, let's first of all compare this triangle with this triangle and see if they're similar. So here we go. Smallest side over here, 4 would go with 6, equals 8 would go with 10, equals 10 would go with 12. Well, 2/3 equals 4/5 equals 5/6. I don't think so. So absolutely not. This triangle here is not similar to this triangle right here. Now let's test this triangle and see if it's similar to this triangle over here. So here we go. Let's go with smallest side over here, which is 4, over smallest side over there, which is 10, equals next length would be 8 over 20, and then the longest side, 10 over 25. Well, if you reduce this, you get 2/5. If you reduce this, you get 2/5. And if you reduce this by 5, you get 2/5. So yes, this triangle here is similar to that triangle there. And then last but not least, number 13. Number 13 kind of looks like this. Got a triangle there, and then one there, and then one there. And let's see, we got a 18, 33, and 27. So 18, 33, and 27. 30, 40, and 22. So 30, 40, and 22. And then we got a 36 and a 24 and a 44. All right, well, let's take this triangle here first and compare it to this triangle here and see if they're similar. Smallest side on this triangle is 18. That would correspond with 22 over here, equals. Next size would be 27. That would correspond with 30. And then the longest side over here is 33, and that would correspond with 40. Well, first of all, I don't think 33 over 40 can be reduced at all. So if it can't be reduced, then it's not equal to any of these. So the answer is no. So this triangle here is not similar to any of those triangles over there. Now let's compare this triangle here with this triangle over here. So here we go. All right, let's start with the smallest side over here, which is 18, corresponding with the smallest side over here, which is 24. I'm going to go ahead and reduce that. You get 3/4, by the way. And now the next size would be 27, and that would correspond with 36. Let's go ahead and reduce that. 9 goes into both of those numbers, 3/4. And now let's take the biggest side over here, which is 33, and that would go with 44. If you reduce that, you get 3/4. So the answer is yes. Yes, this triangle here is similar to this triangle here. All right, moving on to numbers 15 through 26. 15. All right, now I'm not going to draw the triangles for these because we're using side angle side. So look at number 15, please. The first triangle has a side angle side, and the other triangle has a side angle side. Do you see that okay? Well, first of all, are the two angles congruent? Yes, they are. We have 50 degrees is congruent to 50 degrees. Now let's check the sides and see if they're proportional. Well, 6 would correspond with 9, smallest with smallest, while 8 would correspond with 12. Well, let's reduce those. We do get 2/3, and we do get 2/3. So yes. And I'm not going to keep writing they ask for a similarity statement. I mean, I'll do it real quick. I don't want to do it every single one. We'll say triangle ABC is similar to triangle DFE. DFE. All right, let's try number 16. number 16. All right. Do we have side angle side of one triangle and side angle side of another? Yes, we do. And look what we have. We have angle H is congruent to angle X, so that's good. Now let's compare smallest side 12 over smallest side 6, and then 26 over 13. This would give you 2, and this would give you 2. So yes. And you would say triangle GHJ is similar to triangle ZXY. All right, let's continue on to number 17. All right, well, we have 110 degrees is congruent to 110 degrees, and the smallest side 6 would correspond with 8, and then 8 would correspond with 10. And I don't think these are going to be similar. We get 3/4 over 4/5. So no, these two triangles are not similar. All right, number 18. Now be careful on this one. You do hopefully know by now that when you've got something like this, please don't forget that this angle right here is congruent to this angle here. Whenever two lines intersect, their vertical angles are congruent. So please don't forget that. And then we have a 25 here, and we have a 15, a length of 15 right here, and then a length of 18 here, and a length of 30 here. Now if I were to split these two triangles right here, and I wonder if I can do that. I probably can't, but I sure will try. Yeah, I did not think that would work. Okay, that's fine. All right. If I were to split these two triangles, I would have a triangle like this. Oops, that's horrible. Sorry about that. And this angle would be congruent to a triangle like this. And that triangle, or that angle there would be congruent. And I would have a 25 here, and a 15 here, and a 18 here, and a 30 here. So I have side angle side, the angles are congruent. And I would take the smallest side over here, which is 15, and put with the smallest side over here, which is 18, equals smallest side over here, 25, and the smallest side over here, or the biggest side is 25, biggest one is 30. If you reduce this, you would get 5, 6, and if you reduce this, you would get 5, 6. Very good. There we go. So these two triangles are similar. All right, let's take a look at number 19. Number 19. Show that these triangles are similar. All right. Well, here we go very quickly. All right. And then the book has 21 and 9. So 21 here, 9 here, 6 here, 14 here, A, B, C. A, B, C, D, E. All right, first thing I'm going to do is I'm going to take the top, or the small triangle, and put it right there. And I'm going to call that A, D, E. Do you see that okay? A, D, E. That's 9, and that's 6. And now I'm going to draw the really big triangle. And I'm going to call that, this length here is 21, 30. 21 plus 9. And this whole side over here would be 20. And we'll call this B, A, C. Now, do you notice how these two triangles share a common angle A? So this angle here is congruent to this angle here. So I have side angle side, side angle side. Notice how the middle angle is congruent. So now let's check for similarities. The smallest side 6 goes over the smallest side here, which is 20, equals, if I reduce this, by the way, I get 3/10. And the next size over here would be 9 over 30. And 3 goes into both of those, and I would get out 3/10. So check. Yes, these two triangles are similar. Okay, let's take a look at number 20. Number 20. And this is really redundant. These are done the exact same way, but we'll go ahead and work them out quickly for those that might be struggling. Okay, and then we'll put a line right here. So we have, let's see, J, M, K, L, N, L, N, and a 10 and a 4. This is a 10, this is a 4, and this is a 8, and this is a 20. Okay, first of all, the little triangle right here, it's not that little, but the little triangle would look like this. And we would have a 10 here. Yeah, let's go ahead and kind of make that side look more like a triangle. Wow, that's really bad. Alright, we'd have a 10 here and a 20 here, and this is J, M, N. And then the big triangle, now notice we would have a 14 here because 10 plus 4 is 14, and a 28 here, and we would call this J, K, L. You can see what angle they share. They share angle J. So we have side angle, side, side angle, side. The angles are congruent. So we're going to put our smallest side here, 10, with the smallest side down here, which is 14. And then 20 over 28. Reduce, and you get 5/7. And reduce by 4, and you would get 5/7. Alright, so yes, these two triangles are similar. Yes, they are. Alright, moving on to 21 through 26. Alright, and let's see if we can't make a little bit of headway here in this stuff. Alright, we have 35, 35, and 28. So 35, 35, 28, and then 10, 10, and 8. 10, 10, and 8. Now listen, right away we know we're dealing with side, side, side. We have 3 sides and 3 sides. So smallest side over here is 28. Over the smallest side over here is 8. If you reduce that, you would get 7 over 2. Alright, now we take 35 and put it over 10. So 35 over 10, and that would reduce to 7/2. And then the other side over here, 35 goes with 10. So 35 over 10 again, that would give us 7 over 2. So yes, they're similar by what theorem? Side, side, side similarity theorem. And then it says state the similarity. So I'm really going to skip this, guys. I'll be honest, we've done so many of these. The main thing is, are you able to show that these two triangles are similar? That's the main thing. All right, number 22. Oh, good, they're reviewing on this. I like it. Good deal. All right, you got a triangle that looks like that, and a triangle that's a little bigger, and they give you 2 angles on this. Cool. So 74 degrees here, 72 degrees here, 34 degrees here, and 72 here. Well, remember, for angle, angle, all that you need is 2 angles in one triangle congruent to 2 angles over here. Let's add these together. We get 106. So this has to be 74. So look at that. This has to be 74. So I've got 1 angle congruent to 1 angle, 1 angle congruent to 1 angle, and that's called the angle-angle similarity theorem. All right, there we go. So yes, these two triangles are similar. All right, let's take a look at number 23. Number 23. Okay, we have a right angle here and a right angle here. This is a 5, this is a 3. This is the 4 and the 6. So it looks like we're going to try for side angle side. Side angle side, side angle side. We have the angles congruent. So we say the smallest side 3 goes over the smallest side over here, 3/4, equals 5/6. Not true. The answer is no. Absolutely not. Absolutely not. All right, number 24. Number 24. look like this and this and this. $18, $20, $32, $14, $15, and $24. Looks like we're going to have to try the old side, side, side similarity. So smallest side over here is 18. That would go with the smallest side over here, which is 14. Reduce that, and you get 9/7. Okay, the next side length over here would be 20, and that would correspond with 15. And no, there is no way that we can stop right now. There's no way 9/7 is going. If you reduce this, you'll get 4/3. So no. All right, let's try number 25. Number 25. Okay, one triangle looks kind of like that, and the other one kind of like that. All right, let's see if these two triangles are similar. We have side angle side, side angle side. Notice how the angles are congruent. 37 is congruent to 37. Smallest side over here, sorry about that. Smallest side over here in this triangle is 24. Smallest side over here is 20. Equals, next size would be 30 over 25. Well, let's see, 4 goes in both these numbers, you get 6/5. And 5 goes into both these numbers, you get 6/5. So the answer is yes. These two triangles are similar by what theorem? Side angle side. Side angle side. And then number 26. Number 26. This will be interesting. Okay, now let's please watch this carefully, okay? If I take this little triangle right here and copy it to right here, I would have that. And then take the big triangle and copy it right here. I would get that. Now, one thing they tell us, this is a really hard problem, but one thing they tell us is this line here is parallel to this line here. Now remember, whenever two parallel lines are cut by a transversal, see that transversal right there? Two parallel lines cut by a transversal. Well, whenever you have that, please don't forget that what that means is corresponding angles are congruent. So I can state that this angle here is congruent to this angle here, or in other words, this angle is congruent to this angle. Okay? And then don't the two triangles share this angle right here? Sure they do. So there we go. As soon as we know that an angle in this triangle is congruent to an angle over here, and an angle in this triangle is congruent to an angle over here, we can say yes, they're similar by angle, angle. Okay, I hope this has been of a help to you. I'm a little tired, a little bit past midnight, so I hope I've been pretty coherent, but I hope this has been a help to you.